You are on Mars. The dust under your boots has the texture of fine talcum powder, and each step leaves a perfect impression in the reddish surface that will likely remain undisturbed for thousands of years. You stand beside the lander. Its white and silver hull reflect the strange butterscotch light of the Martian afternoon. And for the first moment since landing, you simply stand still and look around. The landing site spreads out in every direction as a flat plain of rusty soil scattered with rocks. Some angular and dark, others rounded and pale, all of them silent witnesses to eons of Martian weather. And there, dominating the entire western horizon, like a wall stretching north and south farther than you can see, rises Olympus Mons, the mountain you came here to climb. The gravity feels lighter than you expected, even after all the training in simulators and reduced gravity aircraft back on Earth, where they tried to prepare you for this. Each movement requires less effort than your muscles instinctively provide, making you feel slightly buoyant, as though you might float if you pushed off too hard from the ground. You weigh about a third of what you weigh on Earth, your body and spacesuit and backpack together, totaling maybe 50 kilograms in this reduced pull, instead of the 130 you carried during training. The sensation takes getting used to, this constant feeling that you are stronger than you should be, that every step could become a leap if you let it. You are listening to the Drowsy Astronaut, and tonight you are not just hearing about Mars or about Olympus Mons. You are experiencing the journey, living the climb from this moment at the landing site all the way to the summit, 22 kilometers above where you will stand on the highest point any human has ever reached. We will take our time with this ascent, staying present in each stage of the journey, feeling what it is like to be here, to walk on another world, to climb a mountain larger than anything Earth has ever produced. If you are listening from somewhere tonight, maybe from bed or from a quiet room, feel free to share where you are in the comments. And if this journey brings you some peace or wonder, a like or subscription helps us keep making these slow explorations through space. Now let us return to the landing site, to your first minutes standing on Martian soil, to the beginning of everything that comes next. The sky above you is not blue, but a warm peachy tan color, lighter near the horizon and deepening to a pale brownish hue overhead. Nothing like the deep azure you grew up under on Earth. The difference comes from the dust, fine particles of iron oxide suspended in the thin atmosphere, scattering light in ways that turn the Martian day into shades of amber and rust. The sun hangs in that strange sky, smaller than it appears from Earth, about 2/3 the size, its light weaker and cooler, giving everything a softer quality. The shadows are still sharp where they fall, but the overall illumination feels gentler, almost like late afternoon on Earth, even though local time shows early afternoon here. The ground beneath your boots is mostly fine dust over harder substrate, and when you crouch down to look closely, you can see the individual grains, tiny fragments of basalt broken down by billions of years of temperature swings and oxidation. The dust clings to everything it touches, coating your gloves when you brush the surface, sticking with a faint static charge that makes it hard to wipe away completely. Scattered across this dusty plain are rocks of various sizes, the nearest one about the size of a basketball, sitting half buried a few meters from the lander. You walk over to it, each step a gentle bounce, and kneel beside it to examine its surface, seeing the pitting and weathering that speaks of unimaginable age. The rock is darker than the surrounding soil, likely a chunk of basalt from some ancient lava flow that covered this region long before Earth had continents or oceans. Its surface shows tiny pits and grooves worn by wind-blown dust over millions of years. The Martian wind, slow and weak in the thin atmosphere, but relentless over geological time. You place your gloved hand on the rock and feel the cold even through the insulated material. The temperature here in the afternoon, only around -20 degrees Celsius. Later tonight, it will plunge to -80 or colder, temperatures that would freeze carbon dioxide out of Earth's air, but are routine here on Mars. Standing up again, you turn your attention fully to Olympus Mons, and the scale of what you are seeing takes some time to comprehend fully. The mountain does not look particularly tall from this distance of perhaps 60 kilometers from its base, because its slopes are so gentle that it resembles a broad, low hill rather than a peak. But you know from the maps and images studied during the journey here that what you are seeing extends across more than 600 kilometers. A shield volcano so enormous that its base would stretch from London to Edinburgh if placed on Earth. The summit lies more than 20 kilometers above the Martian reference level, 2.5 times higher than Mount Everest rises above Earth's sea level. The escarpment, the massive cliff that rings the base of Olympus Mons like a wall, is visible even from here as a darker band running along the base of the mountain's bulk. In places, the escarpment rises 6 to 8 kilometers straight up, a sheer cliff taller than any on Earth, formed by some combination of the mountain's weight, causing the surrounding plain to subside, and perhaps by erosion along the mountain's edges. You will need to climb that escarpment before you can even begin the main ascent of the shield slopes above. And the thought of confronting that cliff face brings a mixture of anticipation and calm focus. The route has been planned, the equipment tested, the cliff has been climbed before by robotic surveyors, and you have trained for this for years. The silence here is absolute, in a way that Earth never achieves. No wind at the moment, no sounds except those you make yourself, and the faint mechanical hum of your life support systems. The atmosphere is less than 1% the density of Earth's air, too thin to carry sound effectively, too thin to breathe, too thin to protect against radiation or to hold heat. Your spacesuit handles all of that, providing pressure and oxygen, regulating temperature, shielding you from the sun's ultraviolet and from cosmic rays that strike the surface unimpeded by any substantial atmosphere. The heads-up display on your helmet visor shows all systems green, oxygen levels good, battery power at 98%, suit temperature comfortable. You walk a slow circle around the lander, testing your movements, getting accustomed to the reduced gravity and the feel of the terrain underfoot. The suit moves well, its joints and bearings working smoothly, despite the dust that has already begun coating every surface. Each step produces a small puff of dust that settles back down almost immediately in the thin air, lacking the buoyancy that would keep it suspended longer. The boot prints you leave are crisp and deep, pressed into the fine powder And when you look back at the trail you have made, you can see each individual step clearly. Those prints will outlast you, remaining visible for thousands or perhaps millions of years, unless some unusual dust storm passes directly over this spot and fills them in. The lander sits squat and stable on its 4 landing legs, its hull already filmed with the reddish dust, despite having been here less than an hour. The descent stage below holds the supplies you will not need for the climb, backup equipment, and samples collected during the landing approach. The fuel reserves that remain after the powered descent. The ascent stage above, where you spent the landing itself, strapped into the acceleration couch, holds the rover you will use to approach the mountain, along with the climbing gear and camping equipment packed into every available space. You will need to unload the rover soon, drive it down the deployment ramp, and begin the trek toward Olympus Mons before the day grows much older. But for these first minutes, you simply stand and be here, letting the reality of Mars soak in, feeling the difference in gravity and light and silence, watching Olympus Mons rise across the western horizon. You have trained in virtual reality simulations, so realistic you could almost believe you had already been here, walked these plains, climbed that mountain in digital form 100 times. But this is different. The realness of it, the knowledge that the rock under your boots is actually rock and not simulation, that the mountain in the distance is actually there waiting for you. The journey from Earth took 7 months. The descent from orbit took 17 careful minutes. And now you stand at the beginning of the real journey, the climb itself. The sun has moved slightly westward during these minutes of exploration and adjustment, the shadows lengthening by barely perceptible degrees, reminding you that a Martian day is only slightly longer than an Earth day, about 37 extra minutes. You will experience many sunrises and sunsets during the climb ahead, camping on the slopes as you ascend, the mountain so large that the summit lies several days of steady walking away. The route is planned to take you first across this plain to the base of the escarpment, then up and over that cliff to reach the shield's lower slopes, then steadily upward across hundreds of kilometers of gentle grade until the summit plateau and its enormous calderas appear ahead. Each stage will reveal new views, new geology, new experiences of being higher and more exposed on a mountain larger than any human has ever climbed. You check the mission clock and see that 90 minutes have elapsed since landing, time marked by the slow countdown that governs your schedule and your reserves. The plan calls for unloading the rover within the first 2 hours, then spending the remainder of the day checking systems and preparing for departure tomorrow at dawn. Tonight, you will sleep beside the lander, your last night with its shelter and resources, before committing to the journey ahead. Tomorrow, when the sun rises over the eastern horizon and casts its weak light across this ancient plain, you will begin the drive toward the mountain, crossing the 60 kilometers of terrain between here and there, approaching the escarpment, confronting the scale of what you intend to climb. For now, you walk back to the lander and begin the work of unloading, opening the storage bay, and activating the rover's systems, going through the familiar routines of deployment and checkout that occupy your hands, while your mind continues to process the simple, overwhelming fact of being here. The rover hums to life, its battery banks charged and ready, its 6 wheels designed for Martian terrain, its cargo bed holding the equipment you will need for the ascent. You guide it slowly down the deployment ramp, and it rolls onto Martian soil with a gentle bounce, its suspension compressing and extending in the low gravity. And with the rover on the ground beside you, you take one more long look at Olympus Mons, at the mountain that has been your destination for so long. Waiting there, patient and ancient and enormous against the butterscotch sky. The rover rolls steadily across the Martian plain, its 6 wheels finding purchase on the dusty surface and carrying you westward toward the growing wall of Olympus Mons at a pace of about 15 kilometers per hour. You sit in the open cockpit, spacesuit secured and systems monitoring the environment, one hand resting lightly on the control stick that guides the vehicle around larger rocks and through shallow channels. The morning sun climbs behind you in the east, casting your shadow long and sharp ahead of the rover, a dark silhouette against the rust-colored ground. The landing site has fallen behind, visible when you look back as a tiny, bright speck in the distance. The lander already seeming impossibly small and far away, though you have traveled less than half an hour. The terrain here consists of ancient basaltic plain, flat in the largest sense, but textured with countless small variations when examined closely. Gentle undulations and shallow depressions that might be old impact craters, softened by eons of dust deposition. The rocks scattered across the surface come in different types, some dark and fine-grained, others lighter and more weathered, a few showing the vesicular texture of gas bubbles frozen in lava as it cooled. You steer around the larger ones and simply roll over the smaller ones, the rover's suspension absorbing the bumps with gentle rocking motions. The dust itself rises in small plumes behind the wheels, though it settles quickly in the thin atmosphere, lacking the air to support dust clouds like those a vehicle would raise on Earth. Olympus Mons has grown noticeably larger in the time since you started driving, the escarpment now visible as a definite feature rather than just a dark band, a cliff face that extends north and south as far as you can see in both directions. The mountain curves away beyond the horizon, its base so enormous that you cannot see its edges from this viewpoint on the ground. From orbit, during the descent, you saw the whole structure, a roughly circular shield with the escarpment forming an irregular ring around its base. The shield slopes rising gently above that to the summit plateau, some 600 kilometers across. But from here on the surface, you see only the nearest section of that immensity, a wall of rock rising from the plain, the bulk of the mountain climbing beyond it. The distance to the base of the escarpment is roughly 60 kilometers from the landing site, a journey that will take several hours at the rover's steady cruising speed across this terrain. You could drive faster, the rover capable of perhaps 30 kilometers per hour on smooth ground. But there is no rush, and the slower pace allows you to observe the landscape, to notice features and formations, to simply experience the act of crossing the Martian surface. The ride feels smooth despite the rocky ground, the reduced gravity making even significant bumps feel gentle, the rover seeming to float over obstacles that would jar heavily in Earth's gravity. You find a rhythm in the driving, small corrections to avoid rocks, gentle acceleration and deceleration, the landscape sliding past at a walking pace, multiplied several times over. The light has a quality you are still adjusting to, softer and warmer than Earth's sunlight. The butterscotch sky, creating an illumination that feels like perpetual late afternoon, even though the sun has only recently risen. Colors appear muted, the reds and oranges of the soil deeper and richer, the blacks of basalt rocks looking somehow warmer than they would under Earth's blue sky. Your spacesuit's faceplate filters some wavelengths for safety, but mostly what you see is Mars as it actually appears, dusty and ancient and painted in shades of rust. The horizon curves gently, Mars being a smaller world than Earth. The distance to the visible horizon only about 3 kilometers at eye level, compared to 5 kilometers on Earth. As you drive, you notice variations in the surface, areas where the dust lies thicker, and others where bare rock shows through. Places where ancient lava flows created slightly different textures or colors in the stone. Some sections show what might be very old, very degraded crater rims, circular rises barely a meter high, enclosing depressions that have been largely filled in by billions of years of dust accumulation. Other areas are smoother, perhaps places where dust has collected more thickly, creating level plains between the rocky patches. The geology here represents billions of years of Martian history, lava flows from when the planet was more volcanically active, impacts from asteroids and comets, slow erosion by wind and temperature changes. The temperature has risen slightly since dawn, your suit sensors showing the outside air at around -30 degrees Celsius now. Cold, but not as brutally cold as the nighttime lows. The thin atmosphere provides almost no insulation, so temperatures swing dramatically between day and night, the ground absorbing solar heat during the day and radiating it away rapidly after sunset. Your suit maintains a comfortable 20 degrees inside, regardless of external conditions, heating and cooling systems adjusting automatically. So you feel none of the cold except as an abstract number on your display. But you can see the effects in the frost that sometimes appears in shadowed areas, water ice or carbon dioxide ice, depending on the temperature, sublimating slowly when sunlight reaches it. After another hour of driving, you stop the rover to rest and check systems, and to simply sit and look at where you are and where you are going. The silence returns when the rover's motors quiet, that absolute Mars silence, broken only by the faint sounds of your breathing and the soft mechanical whispers of the life support system. Olympus Mons now fills a significant portion of the western horizon, the escarpment much clearer, details of its cliff face beginning to resolve. Layers of ancient lava flows, stacked like pages in a book of stone. The summit remains invisible from this angle, hidden beyond the curve of the shield's lower slopes. But you know it is there, 20-something kilometers above the plain. Higher than you can imagine standing here at base level, you drink water from the suit's internal reservoir, the tube positioned near your mouth. The water cool and clean, tasting faintly of the purification system. The act of drinking in a spacesuit is something you practiced countless times in training, but here on Mars, it carries a different weight, a reminder of how dependent you are on the systems keeping you alive, how hostile this environment would be without the technology wrapped around you. The suit pressure holds steady at 1 atmosphere, Earth normal, while outside the pressure is less than 1% of that, so low that exposed water would boil even at these freezing temperatures. Your lungs breathe oxygen-enriched air, comfortable and easy, while the Martian atmosphere consists mostly of carbon dioxide with traces of nitrogen and argon, unbreathable and toxic. Looking back east, toward the landing site, you can still just barely make it out, a tiny bright point on the horizon. And beyond it, the sun continues its climb into the butterscotch sky. Looking west toward Olympus Mons, the escarpment rises like a wall, and you realize that very soon, perhaps within another hour of driving, you will be close enough to feel its scale. To stand at its base and look up at kilometers of vertical rock, the thought brings a calm anticipation, not anxiety or fear, but a readiness, a sense that the real journey is about to begin. Crossing the plain has been a journey in itself, but the plain is flat and easy, the climbing equipment still stowed and unused. At the escarpment, everything will change. You start the rover again and continue westward, the wheels gripping the dust and propelling you forward, the mountain growing larger with every kilometer traveled. The terrain begins to show subtle changes, a slight upward grade that you notice only on the display showing elevation gain, the plane rising gently as it approaches the mountain's base. Rocks become somewhat more common, perhaps debris from the escarpment shed over millions of years, and scattered by rare windstorms across the surrounding terrain. Some of these rocks are quite large, the size of cars or small houses, forcing you to detour around them, their surfaces pitted and weathered, but still solid. Basalt and other volcanic rocks that will last millions of years more. The escarpment continues to grow in your vision, details becoming clearer, the layered structure of its cliff face visible now as horizontal bands of slightly different colors and textures. Each layer represents a separate lava flow from some ancient eruption. Flows that built Olympus Mons over millions or tens of millions of years, layer upon layer of molten rock spreading out from the summit region and cooling into solid stone. The cliffs formed later, perhaps when the weight of the mountain caused the surrounding plain to sink, or when erosion ate away at the mountain's edges, leaving this steep boundary between the shield and the plain. The exact mechanism remains debated among geologists, but the result is undeniable. A cliff face that in places rises 8,000 meters, taller than any cliff on Earth. As you approach closer, the escarpment begins to dominate everything ahead, a wall that seems to extend infinitely north and south, curving away beyond sight in both directions, its top lost in the bright butterscotch sky. You slow the rover, navigating more carefully now through increasingly rocky terrain, your eyes moving between the ground immediately ahead and the growing wall of stone beyond. The base of the escarpment is still perhaps 5 or 10 kilometers away, but its presence has become overwhelming, a vertical barrier between you and the mountain you came to climb. The summit of Olympus Mons remains invisible beyond that barrier, hidden by the escarpment itself and by the shield's bulk rising beyond it. You notice changes in the light as you enter the mountain's influence, subtle shifts in shadow and illumination as the escarpment's mass begins to block the low sun from certain angles. The temperature sensor shows a slight drop, perhaps the cliff face creating its own microclimate, blocking solar heat from reaching the ground near its base. The ground here shows more variation, ancient debris from rockfalls mixed with the ever-present dust, chunks of basalt ranging from fist-sized to boulder-sized, scattered across your path. You slow the rover further, taking time to choose your route carefully, avoiding the largest obstacles and picking a path through the rubble field that extends outward from the cliff base. And then, the escarpment is directly ahead, rising from the plain like a breaking wave frozen in stone, its face tilted slightly outward as it climbs. Layers of lava flows, clearly visible as horizontal striations in the rock. You stop the rover, perhaps 200 meters from the base, knowing you will proceed on foot from here, and you simply sit and look up, tilting your head back to try to see the top of the cliff. It disappears into the sky kilometers above, too high to see its upper edge from this close position, the rock face filling your entire upward view. This is the escarpment of Olympus Mons, the barrier you must climb before the real ascent can even begin, and its scale makes you feel very small and very alive. Standing at the base of the escarpment with your neck tilted back as far as the suit helmet allows, you try to comprehend the vertical distance rising above you into the butterscotch Martian sky. The cliff face extends upward for kilometers. The exact height at this location, difficult to judge from ground level, but certainly several thousand meters at minimum, and possibly as much as 6,000 or 7,000. Layers of ancient lava flows stack one upon another in horizontal bands that you can trace across the rock face, each band representing a separate eruption from millions of years ago. Molten rock that flowed from the summit region and spread across the growing shield before cooling into basalt. Some layers are darker, others lighter, some thick and some thin, creating a striped pattern in the stone that speaks of Olympus Mons' long volcanic history. The rock itself is basalt, fine-grained volcanic stone, dark grey to black, where fresh but often coated with the reddish dust that covers everything on Mars. You walk up to the cliff face and place your gloved hand against it, feeling the solidity through the suit material, the absolute stillness of stone that has not moved in millions of years. The surface is rough with small irregularities, pits and protrusions, tiny ledges and cracks, the texture created by gas bubbles in the cooling lava and by eons of weathering from temperature swings and wind-blown dust. The rock is cold, colder even than the surrounding air, having radiated away its heat during the night and not yet warmed significantly in the morning sun. Looking along the base of the escarpment in both directions, you see it curve gently away, north and south. Following the rough circle of Olympus Mons' perimeter, at distances too vast to comprehend from this ground-level viewpoint. The base is not a clean vertical meeting of cliff and plain, but rather a complex zone where debris has accumulated from ancient rockfalls, creating a talus slope of broken stone that extends outward from the cliff base at a steep angle. Some of this debris consists of house-sized boulders that fell from high above, impacting the slope and tumbling to rest in positions they have likely held for millions of years. Other debris is smaller, fragments and shards of basalt, weathered free from the cliff face and scattered down the talus over geological time. The route you will climb has been scouted by robotic missions years ago, mapped in detail, and uploaded to your suit computer as a three-dimensional path through the cliff's features. You bring up the route overlay on your helmet display, and suddenly the rock face is painted with a glowing line showing the path, winding upward through chimneys and ledges and accessible faces, avoiding overhangs and unstable sections. The route does not go straight up, but zigzags back and forth across the cliff face, taking advantage of natural features that make the climbing easier or safer. Even following this optimized path, the ascent will take many hours, possibly a full Martian day or more, depending on conditions and your own pace. You return to the rover and begin unpacking the climbing equipment, laying it out on the dusty ground to organize and check before beginning the ascent. The gear includes mechanical ascenders that clamp onto ropes, energy-absorbing lanyards for safety, a portable anchor system that can be hammered into cracks or attached to solid features, carabiners and slings, and specialized tools adapted for use in a spacesuit. Everything is larger and more robust than standard Earth climbing gear, designed to be operated with thick insulated conditions back on Earth. The rope itself is a specialized synthetic that remains flexible in extreme cold, marked every 10 meters with colored bands, coiled in a bag designed to feed out smoothly without tangling. The actual climbing technique will involve a combination of free climbing, where the rock features allow, and mechanical assistance where necessary. The goal being to ascend safely rather than quickly or elegantly. Your spacesuit is not ideal for climbing, bulky and restrictive, compared to the freedom of unencumbered movement, but it has been modified with reinforced knees and elbows, improved joint mobility, and attachment points for gear. The backpack life support system rides lower than standard to avoid interfering with your balance, and the helmet has an extended visor area to improve upward visibility. You have trained in this suit configuration for hundreds of hours in climbing gyms and on Earth cliffs. And while it will never feel natural, it is at least familiar. You check the suit systems one more time before committing to the climb, verifying oxygen reserves, battery levels, coolant capacity, all the critical numbers that determine how long you can remain active. The suit can support you for roughly 12 hours of moderate activity before needing to recharge from the rover's power banks. And the oxygen recycling system can extend your air supply almost indefinitely, as long as power remains available. Water reserves are good, and the suit's waste management system is functioning properly, important for a climb that will last many hours. Everything shows green, all systems nominal, and you feel ready to begin. The first section of the route leads up the talus slope, climbing over and between the boulders that have accumulated at the cliff base, gaining perhaps 100 meters of elevation before reaching the actual vertical face above. You begin picking your way upward through the rocky debris, testing each boulder before committing your weight to it, aware that some of these rocks may be only barely stable after eons of settling. The reduced gravity makes the climbing physically easier than it would be on Earth. Your suit and body weight totaling only about 50 kilos here, versus the 130 they would weigh back home. Each upward step requires less effort. Each pull on a handhold takes less strength, making it possible to climb while wearing a fully loaded spacesuit. The talus slope rises steeply, perhaps 45 degrees in places, and the boulders are jumbled together in chaotic arrangements that create a three-dimensional maze of passages and obstacles. You climb over one boulder, squeeze between two others, balance across a third, constantly moving upward using hands and feet to maintain 3 points of contact, as climbing safety demands. The suit scrapes against rock surfaces with quiet, rasping sounds, and dust from disturbed surfaces puffs into the thin air before settling quickly. Your breathing increases slightly with the effort, and the suit's cooling system activates to manage the heat your muscles generate, circulating coolant through channels in the suit liner. After perhaps 40 minutes of climbing through the talus, you reach the base of the actual cliff face, where solid intact rock rises vertically from the boulder field. This is where the technical climbing begins, where you will need to use the rope and anchors and all your training. You find a solid horn of rock and secure an anchor to it, clipping the rope through and testing the setup with your full weight. The anchor holds firm, and you begin to climb, following the route marked on your display, finding handholds and footholds in the natural features of the basalt. The rock provides good grip despite the dust, its rough texture offering plenty of friction, and the horizontal layering creates natural ledges every few meters where different lava flows meet. The climbing motion settles into a rhythm. Reach up and find a hold. Test it. Move your weight onto it. Bring your feet up to new positions. Reach up again. Continuous upward movement at a steady pace. Your heart rate increases, but not excessively. The reduced gravity compensating for the weight of the suit, the oxygen flowing cleanly into your lungs. The cliff face tilts outward slightly, not quite vertical, making the climbing less strenuous than it would be on a truly vertical or overhanging face. You move upward 50 meters, then 100, then 200, the ground below gradually falling away, your world narrowing to the rock in front of you and the route marked on your display. You reach a wide ledge about 300 meters up the face and stop to rest, sitting with your back against the cliff and your legs extending out across the ledge's relatively flat surface. From here, the view has opened up considerably, the Martian plain visible spreading eastward toward the horizon. The landing site, no longer visible at this distance, but the general area marked on your suit's navigation display. The talus slope below looks small now. The boulders that seemed huge when you climbed through them reduced to dots scattered across the cliff base. The rover sits among them like a tiny toy, and you realize how much height you have already gained. But looking up, the cliff continues for kilometers more. The top, still invisible, lost in the height and the sky. The second major pitch of the climb follows a chimney, a vertical crack in the rock face, wide enough to fit your body, and you ascend by bracing your back against one wall and your feet against the other, pushing upward in a technique called chimneying. The suit makes this awkward, its bulk preventing the smooth movements you could achieve with an unencumbered body, but the reduced gravity helps, allowing you to maintain pressure against the walls with less effort. You inch upward, meter by meter, the chimney rising for perhaps 80 meters before opening onto another ledge system. Your thighs burn slightly with the effort, despite the low gravity, and you pause frequently to rest and let your muscles recover. The sun has climbed higher during the hours of ascent, and its light now strikes the cliff face more directly, creating sharp shadows in cracks and overhangs, illuminating the layered texture of the lava flows. The temperature has risen slightly, your suit sensors showing minus 20 degrees Celsius outside, and the rock has warmed enough that frost no longer appears in shaded areas. You continue climbing through the midday hours, moving upward hundreds of meters, the cliff face revealing its structure, layer by layer, each lava flow a page in the mountain's history. Some flows are thick and massive, others thin and delicate, some vesicular with gas bubbles, and others dense and solid, each telling something about the eruption that created it. At one point, you encounter a section where the rock has fractured, a vertical crack running up the face for hundreds of meters, and you must traverse sideways across exposed rock to bypass the unstable area. The traverse requires careful movement, each handhold tested before trusting it, the exposure becoming significant as you move out across the face with only the rope for protection. But the rock holds, and you complete the traverse without incident, reaching stable stone on the far side and continuing upward. The climbing has taken on a meditative quality, the repetitive motions and constant focus, creating a state where thought quiets and only the immediate moment exists, the rock and the route and the movement. Hours pass, measured by the sun's slow arc across the butterscotch sky, and you climb upward through the afternoon, gaining elevation steadily, the cliff face scrolling past handhold by handhold. The route markers guide you through the complex terrain, and your body finds efficiency in the movements, muscles adapting to the suit's restrictions and the reduced gravity. And gradually, after what your mission clock shows as nearly 8 hours since beginning the climb, the angle begins to ease, the vertical face transitioning to steep slope, and you realize you are approaching the top of the escarpment, nearing the point where the cliff gives way to the shield slopes above. The final section of the escarpment climb angles back from vertical to perhaps 70 degrees, steep enough to require hands for balance, but no longer a sheer face. And you scramble upward with increasing speed as the difficulty eases. Loose rock becomes more common here, fragments weathered free from the cliff above and scattered across the slope, requiring careful foot placement to avoid dislodging stones that could tumble down the face below. You clip your safety line to periodic anchors, driven into more solid sections, maintaining protection even as the climbing becomes less technical. The top edge of the escarpment appears perhaps 50 meters above now, a line where the steep slope meets the sky, and you push toward it with renewed energy despite the fatigue accumulating in your muscles from hours of continuous ascent. Your gloved hands grip a final outcrop of solid basalt, and you pull yourself up and over the edge, rolling onto relatively flat ground and lying on your back for a long moment, breathing heavily, looking up at the sky. The escarpment is below you now, a massive drop falling away to the plain far below. The cliff you just climbed revealed from above as an enormous vertical barrier wrapping around this section of Olympus Mons' base. But you are above it now, standing on the shield volcano itself, on the actual slopes of the mountain rather than at its base. The achievement feels significant, a major hurdle overcome, though you know the escarpment was only the beginning, the true climb still lying ahead. You sit up and look around, taking in the new environment you have reached. The ground here is noticeably different from the plain below, tilted at a gentle but perceptible angle as the shield slope begins. Covered in dust and scattered rocks like everywhere on Mars, but with a quality that speaks of elevation and exposure. Behind you, eastward, the edge of the escarpment marks a clear boundary, the ground dropping away into the abyss of the cliff face, the plain visible far below as a rusty expanse stretching to the horizon. Ahead, westward, the slope rises gently but definitely upward, beginning the long grade that will continue for hundreds of kilometers to the summit plateau. The sun has moved significantly across the sky during the hours of climbing, now descending toward the western horizon, though still well above it, the afternoon aging into evening. Your suit systems show battery reserves at 40%, oxygen recycling functioning normally, water at 60% of capacity, all acceptable levels, but indicating that you will need to camp soon, rather than continuing into darkness. The plan had always called for camping at the top of the escarpment after completing the climb, resting through the night, then beginning the shield ascent tomorrow at dawn. The location offers relatively flat ground and protection from the wind that sometimes sweeps across exposed slopes, making it as good a campsite as you are likely to find. You walk back from the escarpment edge to find a sheltered spot among a cluster of rocks, a place where you can deploy the inflatable habitat module you carried compressed in the rover below. But you realize the rover is still at the base of the cliff, its supplies inaccessible unless you climb back down, or unless you brought what you need. Your backpack holds emergency shelter capability, a minimal inflatable bubble that can provide protection and allow you to partially remove the suit for rest, along with power packs to recharge the suit systems and concentrated food supplies. It is not luxurious, but it will serve for tonight and for the nights ahead during the long climb. You deploy the emergency shelter in the lee of the largest rock, a boulder the size of a small car that blocks the western wind if any should rise during the night. The shelter unfolds from its compressed state and inflates automatically from a small gas cartridge, expanding into a dome shape about 2 meters across and 1 meter high at the center, barely large enough to lie down in. The material is tough, multi-layer fabric with insulation and micrometeorite protection, translucent enough to allow some light through, but opaque enough to provide privacy from the empty landscape. You crawl inside through the airlock collar, a simple double-layered opening that allows you to maintain pressure, and the shelter seals around you. Inside the shelter, you can finally remove your helmet, breathing the confined air that smells faintly of plastic and recycling chemicals, but feels like freedom after hours enclosed in the suit. The shelter maintains pressure automatically, equalizing with your suit at 1 atmosphere, creating a tiny bubble of Earth-normal conditions here on the slope of Olympus Mons. You drink deeply from a water pouch, eat a concentrated meal bar that tastes of nuts and dried fruit, and feel your body begin to relax after the long day of travel and climbing. The fatigue is significant, but not overwhelming. Muscular tiredness mixed with the satisfaction of goals achieved, distance covered, elevation gained. Through the translucent shelter material, you can see the Martian evening developing outside, the light taking on deeper amber tones as the sun lowers, shadows lengthening across the slope. The temperature is dropping rapidly, as it always does on Mars when the sun declines. Your suit sensors showing the outside air at -40 degrees now, and falling toward the nighttime lows that will reach -80 or below. The shelter's insulation and your suit provide protection, and a small heating element powered by the backpack batteries maintains a comfortable temperature inside the bubble. You lie back on the inflatable floor pad, your suit still on but opened at the waist and chest for comfort, and simply rest. The silence outside is absolute. No wind at the moment. No sounds except the faint creaking of your shelter material as it flexes slightly with temperature changes. Mars has no insects, no birds, no rustling animals, no sounds of life, because life does not exist here in any form yet discovered. The planet is geologically active only in the slowest sense. No earthquakes or volcanic eruptions in millions of years, no tectonic plates grinding together, just the gradual processes of erosion and dust deposition playing out across eons. The stillness is profound, peaceful in a way Earth's nature never quite achieves, and you find yourself relaxing into it, letting the quiet fill you. Looking at the mission timeline on your suit display, you see that 14 hours have elapsed since you left the landing site this morning. Time spent driving across the plain and climbing the escarpment. And the plan for tomorrow involves beginning the ascent of the shield's lower slopes. The route from here to the summit covers approximately 300 horizontal kilometers, following a spiral path that switchbacks up the gentle grade, gaining elevation slowly but steadily. The slope averages about 5 degrees, gentle enough that you will walk rather than climb technically, but relentless in its consistency, never leveling, always rising. The distance means the ascent will take days, camping each night wherever you happen to be on the slope, carrying minimal supplies, and relying on the suit systems to sustain you. Water can be replenished from ice deposits that appear at higher elevations, melted using the suit heating elements, and the food concentrates you carry provide enough calories for 2 weeks of heavy activity. Power is the main constraint. The suit batteries requiring recharging from solar panels you will deploy at each camp. The Martian sun weak, but adequate for slowly replenishing the reserves. The climb is designed to be self-sufficient, carrying everything needed, moving upward day by day until the summit plateau appears ahead. You activate the shelter's exterior camera view on your display, seeing the landscape outside from multiple angles, and watch as the sun touches the horizon and begins to set. The sunset on Mars progresses quickly, the thin atmosphere providing little twilight. The transition from day to night happening over minutes rather than the long dusk Earth experiences. The sun appears smaller than from Earth, about 2/3 the diameter, and its color is less intense, the light filtering through dust to create a pale yellow disk that sinks steadily downward. As it touches the horizon, the sky around it briefly shows blue, a counterintuitive effect caused by the way dust scatters light at extreme angles, creating a small region of blue around the sun during sunrise and sunset. The blue fades as the sun sinks further, replaced by deepening oranges and reds. And then the sun is gone, dropping below the horizon, leaving the sky to darken rapidly. Stars begin to appear, faint at first, then brighter as the sky blackens. More stars than you ever saw from Earth's surface, except in the darkest wilderness areas. Mars has no light pollution, no atmospheric haze to speak of, and from this elevation on Olympus Mons, the view of space is remarkably clear. The Milky Way becomes visible as a glowing band across the sky, countless stars clustering along the galactic plane, and you can make out details in its structure, dark lanes of dust, silhouetted against the glow. You watch the stars for a long time, lying in the shelter with the camera view displayed, identifying constellations that look almost the same from Mars as from Earth. The distances to the stars being so vast that the change in viewpoint from Earth to Mars makes no visible difference. Orion hangs in the eastern sky, the 3 belt stars aligned, and the bright stars Betelgeuse and Rigel, marking the hunter's shoulder and foot. Canis Major sits below with Sirius, shining brilliantly, the brightest star visible from this side of the solar system. The stars turn slowly as Mars rotates, the same rotation that drives the day-night cycle, a Martian day being only 37 minutes longer than Earth's. Eventually, you close the camera view and settle in for sleep, setting a soft alarm for 1 hour before dawn, giving yourself time to pack the shelter and prepare for the day's climb before the sun rises. Sleep comes easily despite the strangeness of the location, exhaustion from the long day, overcoming any restlessness you might feel. You dream fragmentary dreams of climbing, of rock faces scrolling past, of endless upward movement through stone and sky. And the night passes in the deep silence of Mars, with the stars wheeling overhead and the temperature dropping to cold that would kill an unprotected human in minutes. But inside the shelter, inside the suit, you sleep peacefully, your first night on the slopes of Olympus Mons. The alarm wakes you gently, a soft chime in the darkness, and you activate the shelter lights, dim red illumination that preserves your night vision while allowing you to see. Outside, the camera views show total blackness. The sun still below the horizon, the stars still bright overhead. You eat another concentrated meal, drink water, check the suit systems, and find them all charged and ready. The solar panels having captured enough weak sunlight during yesterday's afternoon to replenish the batteries. The shelter packs back into its compressed state in a few minutes, and you seal your helmet and equalize pressure with the outside, then open the airlock and crawl out into the Martian night. The cold is intense, minus 90 degrees Celsius, according to your sensors. The suit heating working steadily to maintain comfortable temperature inside. You can see your own shadow cast by starlight alone, faint but visible on the dusty ground, Mars providing just enough natural illumination to navigate by without activating your suit lights. But you turn on the helmet lights anyway, bright LED beams that illuminate the slope ahead, showing the gentle upward angle, the scattered rocks, the route you will follow as soon as the sun rises. You walk to the escarpment edge, one more time, looking out over the drop to the plain below, now invisible in darkness, just a vast, empty blackness stretching to the horizon. And then you turn westward, facing upslope, facing the bulk of Olympus Mons, rising into the darkness ahead. Its summit still hundreds of kilometers away, and more than 15 vertical kilometers above where you stand. The mountain is invisible in the night, too vast and too dark to see, except as an absence of stars in that direction, where its mass blocks the sky. But you know it is there, waiting, patient and ancient as it has waited for millions of years. And when the sun rises, you will begin walking upward into that vastness, beginning the long, slow ascent that will carry you higher than any human has ever stood. The eastern sky shows the faintest hint of light now, the stars dimming as dawn approaches, and you stand in the cold darkness and wait for the sun to rise on your second day on Mars. The sun lifts above the eastern horizon with surprising quickness, the Martian dawn lacking the prolonged twilight of Earth. The transition from night to day compressed into a few minutes, as the thin atmosphere provides little medium to scatter light before the source appears. The butterscotch sky brightens, stars fading rapidly, and suddenly the sun itself emerges, a small pale disk climbing into view. And the landscape around you transforms from shadowed darkness into the rust and amber tones of Martian daylight. The slope ahead becomes visible, rising gently but definitely westward, extending upward as far as you can see, until distance and the curve of the shield hide the upper reaches. This is the beginning of the true climb, the ascent of the shield volcano's flank. A walk that will continue for days across hundreds of kilometers of gradually rising terrain. You begin walking upslope, each step covering about a meter, the gentle grade barely noticeable at first, like walking across a field that happens to tilt slightly upward. The surface under your boots consists of fine dust over harder substrate, with rocks scattered at irregular intervals, some barely larger than pebbles, and others massive boulders that you detour around. The dust shows no footprints except your own, no marks of any previous passage. This section of Olympus Mons never visited by humans before, and only rarely imaged by orbital cameras. The walking rhythm settles quickly. A steady pace, neither fast nor slow, sustainable for hours, your breathing easy and your muscles warming to the work. The slope angle remains constant at around 5 degrees, gentle enough that the effort feels minimal in the reduced gravity, yet consistent enough that you are always climbing, always gaining elevation. The altimeter on your display ticking upward, meter by meter. For every 100 meters you walk horizontally, you gain about 9 meters of elevation, a grade that would be easy on Earth and is even easier here, where your weight is reduced by 62%. The horizon ahead remains relatively close, Mars being smaller than Earth, and the slope creates an effect where you seem to be climbing toward a nearby ridgeline. Yet when you reach where that ridge appeared to be, it has receded, and another apparent ridge appears the same distance ahead. The landscape is surprisingly varied, despite appearing monotonous at first glance, with different lava flows creating different surface textures, some flows smooth and others rough, some dark and others lighter, each representing a separate eruption from the volcano's active past. You walk across a section where the surface is unusually smooth, a type of lava flow called pahoehi that forms when low-viscosity lava spreads in thin sheets and cools with a ropey texture, the frozen ripples still visible after millions of years. Then the surface transitions to rougher AA lava, a jagged, blocky texture created when thicker lava breaks apart as it flows, forming a surface of sharp fragments that makes walking more difficult, requiring careful foot placement to avoid tripping. Between the different lava flows, you sometimes find boundaries where one flow overlapped another, visible as a distinct line or low step in the terrain. And these boundaries tell the story of Olympus Mons' construction, layer upon layer of eruptions, building the shield higher over geological time. The volcano is ancient, its youngest surfaces possibly 2 million years old, and its oldest parts perhaps 100 million years old, though dating Martian features remains challenging with limited samples. The mountain likely grew through many eruption cycles, periods of activity followed by periods of dormancy, each active phase adding new layers to the growing shield. After several hours of walking, you stop to rest and look back at the route you have covered, seeing your boot prints trailing down the slope behind you in a wandering line that marks your passage. The escarpment is no longer visible from here, dropped below the curve of the shield's lower slope, and the plain beyond has disappeared as well. Your world now bounded by the slope extending upward ahead and downward behind, the horizon close in all directions due to the curvature. The sense of being on a mountain is subtle, the grade so gentle that it feels more like walking across tilted terrain than climbing. Yet the altimeter shows you have gained several hundred meters of elevation since dawn. You drink water from the Soot Reservoir and eat a small concentrated food bar, the nutrition sufficient to replenish what you have burned during the walking. The sun has climbed higher into the butterscotch sky, its weak light warming the surface slightly. Your sensors showing the outside temperature has risen to -20 degrees Celsius. The shadows have shortened and the landscape looks flatter in the overhead light, details washed out by the even illumination. You sit on a convenient rock and simply observe the stillness, the absolute quiet, the sense of being utterly alone on a slope that extends for hundreds of kilometers in every direction. The isolation would be terrifying for some people. Being this far from any other human, days of travel from the nearest help, surrounded by an environment instantly lethal, without the thin barrier of your spacesuit. But for you, it brings a strange peace, a simplification of existence to immediate concerns, the body and the suit and the slope and the goal. There are no distractions here, no messages or notifications or demands, just the walk and the mountain and the thin Martian air that cannot carry sound or scent or any sensation except the cold radiating through the suit insulation. You realize you could stay here for hours, sitting on this rock, watching the light change as the sun crosses the sky, and nothing would disturb you. Nothing would change except the slow rotation of Mars beneath the stars. But the summit lies ahead, still many days of walking distant, and you stand and resume the climb, boots crunching in the dust, legs finding the rhythm again, the slope rising ahead. The afternoon passes in steady walking, the landscape changing in subtle ways, the lava flows varying in texture and composition, occasional features appearing and passing. A collapsed lava tube creating a linear depression you follow for a kilometer, an ancient channel carved by flowing lava during some long-ago eruption. You cross a field of volcanic bombs, solidified blobs of lava that were thrown into the air during explosive eruptions and fell back to the surface while still molten enough to deform on impact, creating rounded or oblong rocks scattered across the slope. The sun begins its descent towards the western horizon, and you start watching for a suitable campsite, looking for shelter from wind and a relatively flat area to deploy the inflatable habitat. You find a spot in the lee of a low ridge, a place where an old lava flow created a step in the terrain about 2 meters high, offering protection from the prevailing easterly winds. The ground here is reasonably level, and a cluster of rocks provides additional windbreak, making it as comfortable a location as you are likely to find on this exposed slope. You stop walking, your mission clock showing you have been moving for about 9 hours today, and begin setting up camp for the night. The shelter deploys as it did last night, inflating into its dome shape, and you crawl inside to rest while the sun sets and darkness returns. Through the camera views you watch the sunset, similar to last night, but from a different vantage point several kilometers higher in elevation. The horizon slightly more distant, the plain below, invisible beyond the curve of the shield's lower slopes. The sky goes through its color changes, the blue around the setting sun appearing briefly before fading to orange, and then darkness. Stars emerge, the Milky Way arching overhead, and you lie in the shelter, feeling the fatigue from the day's walking settle into your muscles. A pleasant tiredness that speaks of work accomplished, and distance covered. You check the navigation display and see you have covered approximately 40 horizontal kilometers today, gaining about 3.5 vertical kilometers. Good progress on the long route to the summit. At this pace, the climb will take 7 or 8 more days, assuming conditions remain favorable and your body holds up to the sustained effort. The suit systems are performing well, all metrics within normal ranges, and you feel physically strong despite the tiredness. Your muscles adapting to the reduced gravity and the constant low-level exertion. Tomorrow you will wake and continue upward, and the day after that, and the day after, climbing higher on Olympus Mons until the summit plateau finally appears. You eat your evening meal, drink water, perform the routine checks on suit systems and supplies, then settle in for sleep. The night outside is profoundly cold and profoundly quiet, the temperature dropping toward -90 again, the wind calm or perhaps just too weak to register on sensors. You sleep deeply, dreaming again of walking, of slopes rising endlessly ahead, of rust-colored dust under your boots and butterscotch sky overhead. The stars turn slowly through the night, constellations wheeling across the Martian sky, and the mountain sleeps beneath them, as it has for millions of years, ancient and patient and vast beyond human scale. Days blend together in a rhythm of dawn departure, hours of steady walking upslope, evening arrival at a new campsite slightly higher and slightly farther west than the previous night's location. You have been climbing for 5 days now since leaving the escarpment top, covering roughly 40 to 50 kilometers each day, gaining 3 to 4 vertical kilometers daily, your body settling into the routine of sustained ascent. The altimeter shows you are now approximately 15,000 meters above the Martian reference level. About halfway to the summit, in vertical terms though, the horizontal distance remaining is still considerable due to the shield's gentle slope. The air pressure outside, already thin at Mars's surface level, has decreased to barely measurable levels. A few millibars, where Earth's sea level measures over 1,000, the landscape has changed subtly with the elevation gain. The lava flows appearing younger on average, less weathered, the surface showing fresher features that have not yet been worn smooth by eons of erosion. The dust layer seems thinner at this altitude, perhaps because the thin atmosphere provides less wind to transport particles upslope, or perhaps because there are simply fewer particle sources nearby. The rocks scattered across the slope show crisper edges and less rounding, their volcanic textures more clearly preserved. You notice features that might be relatively recent, geologically speaking, lava flows that could be only a few million years old rather than tens of millions. Though without detailed analysis, you cannot be certain. The temperature patterns have shifted as well, the daytime highs reaching only -30 degrees now at this altitude compared to the -10 or -20 you experienced lower on the shield, and the nighttime lows dropping to -100 degrees or below. The sun's heating effect diminishes with elevation as the atmosphere thins toward nothing, and the surface here radiates its absorbed heat away rapidly after sunset, with no air to trap warmth. Your suit compensates automatically, increasing heating output during the cold nights and reducing it during the relatively warmer days, managing your thermal environment to maintain constant comfort despite the external extremes. The walking itself continues to feel surprisingly manageable, despite the sustained effort day after day. The reduced gravity and the gentle slope combining to make the physical exertion less than you initially expected. Your muscles have strengthened over the days of climbing, and your cardiovascular system has adjusted to the rhythm of constant, moderate activity. You tire each day, but it is a clean tiredness without the deep exhaustion or soreness that would accompany such sustained climbing on Earth. The suit's life support provides everything you need: oxygen and water, and temperature control, removing the variables that would complicate such a climb in any Earth environment. You have developed small rituals that structure the days, ways of marking time and maintaining morale during the repetitive routine. Each morning, you watch the sunrise before beginning to walk, observing the way the light changes the landscape, from shadowed darkness to rust and amber visibility. Each afternoon, you select 3 interesting rocks or features to examine closely, giving yourself permission to spend a few minutes studying the geology, running your gloved hands over ancient lava textures, considering the volcanic processes that created what you see. Each evening, after setting up camp, you allow yourself 10 minutes to simply sit and watch the stars emerge, a meditation on scale and distance, and the vastness of space surrounding this small planet where you walk alone. The horizon has grown noticeably more distant as you have climbed higher, the curvature of Mars revealing more terrain at increased elevation. And on particularly clear days, you can see what might be the distant edge of the Tharsis region, other volcanic features perhaps visible as low shapes near the limit of vision. Olympus Mons is not the only large volcano on Mars, just the largest, and the Tharsis Bulge hosts several others, including Olympus Mons, Pavonis Mons, and Arsia Mons, all substantial shield volcanoes, though smaller than Olympus. From this height, on Olympus's flank, the other mountains might be theoretically visible given perfectly clear air and correct geometry, though you cannot be certain what you are seeing at such distances. The slope continues upward ahead with no sign of leveling, no indication that you are approaching the summit region, the grade maintaining its relentless consistency. You have walked more than 200 horizontal kilometers from the escarpment base, spiraling gradually around the mountain as the route switchbacks to manage the grade, and perhaps another 100 kilometers remain before the summit plateau. The numbers are abstract, distances so large they lose meaning, and you find it easier to think in terms of days rather than kilometers, perhaps 3 or 4 more days of climbing before the upper slopes. And the final approach. You notice the sky appears slightly darker even during daytime at this altitude, the butterscotch color deepening toward a darker amber, almost brown in places, the thinning atmosphere providing less medium to scatter light. Looking directly upward, the sky takes on a purplish cast during midday, a hint of the blackness that dominates at higher altitudes and in space. The transition from atmospheric sky to the black of space is gradual on Mars, not the sharp boundary that Earth's thicker atmosphere creates, and you are climbing through that transition zone, moving from a place where atmosphere exists thinly to a place where it exists hardly at all. During one afternoon's walk, you encounter a feature marked on the navigation maps as an old lava channel, a depression carved into the slope by flowing lava during the mountain's active past. And you follow it upslope for several kilometers because its floor provides smoother walking than the surrounding terrain. The channel is perhaps 10 meters wide and 2 meters deep, its walls showing the layered structure of lava flows it has cut through. And you can see how the molten rock must have coursed down this channel during eruptions, a river of liquid stone flowing down the shield's slope. The channel eventually shallows and disappears, either filled in by later flows or simply fading out, and you climb back to the surrounding surface level and continue upslope. Another day you find what might be a very old lava tube collapse, a linear pit where the roof of an underground lava tube failed and fell inward, creating a trench about 50 meters long and several meters deep. Lava tubes form when the surface of a lava flow cools and solidifies while liquid lava continues flowing underneath, creating a tunnel. And after the eruption ends, the tunnel may remain as a cave-like feature beneath the surface. On Mars, these tubes can be enormous, potentially large enough to walk through, or even to serve as natural shelters, and future explorers might use them as radiation-shielded habitats. This particular collapse is ancient, the edges rounded by erosion, the interior partially filled with dust and debris. Interesting as a geological feature, but not accessible or useful. The days continue, dawn and walking and evening, the routine becoming meditative in its repetition, your mind quieting as your body performs the familiar motions, hour after hour. You find yourself thinking less and observing more, noticing small details in the landscape, the way shadows fall across rocks, the texture of undisturbed dust, the exact color of the sky at different times of day. Thoughts arise and pass without attachment, memories from Earth surfacing briefly then fading, plans for what you will do after this mission sketching themselves and dissolving, leaving just the present moment, boots on dust, slope rising ahead, mountain enormous and patient around you. On the evening of the 6th day climbing the shield slopes, you camp at an elevation of 18,000 meters above datum, well into the upper regions of Olympus Mons, though still several kilometers below the summit plateau. The air pressure outside has dropped to essentially zero, your sensors barely registering any atmosphere at all. And the sky, even at midday, shows deep purple overhead, fading to dark brown near the horizon. The stars are visible during daylight hours. If you look away from the sun, bright points of light in the purplish sky, the atmosphere too thin to scatter enough light to hide them. You are climbing above Mars's atmosphere, rising into near-space conditions, while still walking on solid ground. An unusual experience that few environments in the solar system can provide. That night, as you lie in the shelter after sunset, you think about the summit waiting above, now perhaps only 2 or 3 days distant, and you feel a mixture of anticipation and something almost like reluctance, an awareness that reaching the summit will mean the climb is ending. The ascent has become its own reward, the daily rhythm satisfying in ways that are difficult to articulate. And part of you wishes it could continue indefinitely, always another day of climbing ahead, always more mountain rising above. But goals exist to be reached, and the summit of Olympus Mons is the goal that brought you across space to Mars, the purpose underlying all the years of training and the months of travel. You sleep peacefully as you have every night on the mountain, the tiredness from walking ensuring deep rest. And in your dreams, you are still climbing, still moving upward through endless landscapes of rust and stone, the slope never quite reaching its end, the summit always another day ahead. The morning of the 7th day, climbing the shield slopes brings a visible change in the sky that confirms your altitude. The butterscotch color now almost gone, except as a thin band near the horizon, replaced overhead by a deep purple blue that in some directions appears nearly black, even with the sun well above the horizon. Stars shine openly in the daytime sky, visible simultaneously with the sun, bright points scattered across the darkness where atmosphere once provided blue or tan, but now provides almost nothing. You are high enough that Mars's thin atmosphere lies mostly below you, the bulk of what little air exists, concentrated in the lower altitudes, leaving this upper region in conditions approaching the vacuum of space. Walking in this environment feels surreal. The landscape illuminated by bright sunlight, yet the sky above showing stars as though it were night. The familiar division between day and night breaking down in the absence of atmospheric scattering. The sun itself appears small and pale, its light weaker than Earth's sun, and you can look in its general direction without the painful glare that would blind you on Earth, though you still avoid staring directly at it for safety. The shadows cast by rocks are absolutely sharp-edged, no atmospheric diffusion softening them, and the contrast between sunlit areas and shadowed areas is extreme. Bright rust and amber where light strikes, and deep black where shadow falls. The slope continues rising at its familiar gentle grade, the surface becoming noticeably younger in appearance. The lava flows here, showing features that might be only 1 or 2 million years old, based on crater counts and weathering states. The rock is darker than lower on the shield, less dust covering the surfaces, the basalt exposed in its natural near-black color that only appears reddish where iron has oxidized over time. You walk across flows so smooth they seem almost glassy. Volcanic glass actually present in some locations where lava cooled particularly quickly. Obsidian-like material scattered in fragments that catch the sunlight with dark reflective glints. The temperature at this altitude during midday has risen slightly compared to the middle slopes, paradoxically warmer despite the higher elevation. Because the thin atmosphere provides less cooling effect, and sunlight strikes the surface with minimal atmospheric absorption, your sensors show -20 degrees Celsius in direct sun, though shadowed areas remain brutally cold at -70 or below. The surface itself varies dramatically in temperature between sunny and shaded sides of rocks, creating thermal stresses that contribute to weathering even in this nearly airless environment. The daily temperature swings, causing expansion and contraction that slowly fractures the stone. During the late morning, you notice the slope angle beginning to change, the grade increasing from the 5 degrees you have grown accustomed to up to perhaps 7 or 8 degrees. A subtle difference, but definitely perceptible after days of constant 5-degree climbing. The navigation display confirms you are approaching the upper shield, a region where the volcano's profile steepens somewhat before transitioning to the summit plateau. And the increased grade means you are getting close to the final sections of the climb. The horizon ahead has begun to show a different quality, less the endless rising slope and more a sense that the slope might actually end at some point, though the summit plateau itself remains beyond your current view. You stop for a rest and turn to look back down the slope you have climbed over the past week, seeing the shield fall away below you in a vast sweep of rusty and grey terrain. The lower slopes visible as a gradual darkening toward the horizon, where distance and dust obscure details. The escarpment is far beyond your visual range now, hundreds of kilometers behind and 6 or 7 vertical kilometers below, the plain beyond it completely out of sight. The view encompasses an enormous area, hundreds of thousands of square kilometers of Martian landscape visible from this vantage point. And you realize you can probably see farther from here than from anywhere you have ever stood before, the horizon lying perhaps 300 kilometers distant in the thin, clear air. The afternoon brings you into terrain that shows distinct evidence of relatively recent volcanic activity. The lava flows here, exhibiting features suggesting ages of perhaps only a few 100,000 years. Young, in geological terms, though still ancient by human standards. The surface is rough with AA lava, sharp, blocky fragments that make walking more difficult, requiring careful foot placement and slowing your pace. Flow features are clearly preserved, frozen rivers of stone showing ripples and pressure ridges, areas where the lava piled up against obstacles or drained away, leaving collapsed sections. You navigate through this complex terrain, finding easier paths where possible, accepting the difficult footing where necessary. Late in the day, you encounter a series of low cliffs, steps in the terrain where different lava flows created level changes. Each cliff, perhaps 3 to 5 meters high, and you must find routes to scramble up them, using hands occasionally for balance, though nothing requiring technical climbing skills. The cliffs add vertical distance efficiently, and you gain 100 meters of elevation over a horizontal distance of only a few kilometers. Speeding your approach to the summit region, between the cliffs, you cross relatively flat areas where lava pooled before overflowing to the next lower level. These flats, covered in smooth paheohe, with beautiful ropey textures frozen in the rock. As the sun descends toward the western horizon, you reach an elevation of 20,000 meters above datum, entering the zone where the summit plateau should begin to appear ahead within the next day, or two of climbing. The slope here has steepened further, perhaps 10 degrees now, still quite walkable, but definitely more demanding than the lower shield's gentle grade. Your muscles feel the difference, thighs working harder to push your body weight upward against gravity, even in the reduced pull. The fatigue each evening has become more pronounced, your body approaching the limits of how much sustained climbing it can handle day after day, though you still feel strong enough to continue. You make camp in the lee of one of the low cliffs you climbed during the afternoon, finding a flat area at the cliff's base where wind cannot reach and the rock face provides a sense of enclosure in the otherwise exposed landscape. The shelter deploys and you crawl inside to rest, removing your helmet and breathing the confined air, drinking water and eating food, and feeling the tiredness settle deep into your muscles. Through the camera, views you watch another Martian sunset, the sun sinking into a sky that is already dark purple, stars visible even before sunset. The transition to night, less dramatic at this altitude, where day and night differ less in sky color and more in the presence or absence of direct sunlight. The stars emerge in their full glory as darkness completes, and from this altitude, with virtually no atmosphere above you, the view of space is extraordinary, rivaling or surpassing anything visible from Earth's surface, even at the best observing sites. The Milky Way stretches across the sky as a river of light, individual stars too numerous to count, nebulae visible as fuzzy patches. The structure of the galaxy laid out overhead, in detail impossible to see through Earth's thick atmosphere. You can discern the dark dust lanes that thread through the Milky Way's spiral arms, regions where interstellar dust blocks the light from stars beyond, creating apparently empty patches against the glow. You notice Earth in the evening sky, a bright blue-white point of light near where the sun set. The planet you came from visible as a star from this distant world where you climb alone. Earth appears brighter than any star except Sirius, its bluish color distinguishable even to the eye, and seeing it creates a complex feeling. Homesickness mixed with satisfaction at the distance traveled and the accomplishment of being here. Beside Earth, you can just make out the moon, a fainter point very close to the brighter planet, the two appearing nearly merged at this distance. They set together below the western horizon, following the sundown, and you watch them go, feeling connected across the gulf of space to that distant blue world. Sleep comes easily, despite the altitude and the thin air outside, your suit maintaining perfect conditions inside, regardless of external environment. And you drift into dreams of starlight and stone, of endless slopes, climbing toward black skies, of standing eventually on the summit with all of Mars spread below, and space beginning just overhead. The night passes in deep cold silence, the temperature outside dropping to minus 110 degrees Celsius, colder than anywhere on Earth's surface, the rock around you radiating its heat into space, with no atmosphere to slow the loss. But you sleep warm and safe in the shelter, the technology that brought you here keeping you alive in this place where human life has no natural place. Morning brings the familiar routine, waking before dawn, packing the shelter, checking systems, eating breakfast, then standing in the pre-dawn darkness, waiting for the sun to rise. The stars overhead are extraordinary in the minutes before dawn, brighter than you have ever seen them. The Milky Way so vivid, it seems three-dimensional, and you stand looking up until the eastern sky begins to pale and the stars fade. The sun rises, small and pale, and the sky brightens to its daytime purple-black, and you begin walking up slope again, continuing the climb, moving toward the summit that must be close now, perhaps visible today or tomorrow, the final goal approaching. The slope steepens again during the morning of the 8th day, the grade now approaching 12 or 13 degrees in places, still walkable, but beginning to feel like genuine climbing rather than hiking. Your legs pushing harder with each step, your breathing deeper, despite the suit providing adequate oxygen. The surface here is young volcanic terrain, rough and fresh-looking, lava flows that might be only a few tens of thousands of years old. Recent enough that crater density is very low, only a few small impacts having occurred since these flows solidified. The rock shows almost no weathering, edges sharp, textures crisp, the basalt appearing nearly as it did when it cooled from its molten state millennia ago. You notice the horizon ahead beginning to level off, the constant rise that has characterized every view for the past week, showing hints of flattening, and you realize you are approaching the summit plateau, the upper region of Olympus Mons, where the shield slope finally ends and gives way to a relatively flat expanse containing the caldera complex. The navigation display confirms that the plateau edge lies perhaps 20 kilometers ahead horizontally and less than 2 vertical kilometers above your current position. Close enough that you might reach it today if you push hard, or more comfortably tomorrow morning if you maintain a steady pace. The knowledge that the summit is near brings a surge of energy despite the fatigue accumulated from 8 days of continuous climbing, and you increase your pace slightly, covering ground faster, eager to finally see the plateau and the calderas that mark the mountain's highest points. The terrain cooperates, a section of smooth pahoaho providing easy walking, and you make good time through the late morning and into the afternoon. The sun climbs to its zenith, such as it is, the small pale disk reaching its highest point in the purple-black sky, and the shadows contract to small pools of darkness directly beneath rocks and cliffs. Around mid-afternoon, you top a slight rise in the slope, and suddenly the view ahead changes. The rising terrain visible for the past week, replaced by a horizon that appears level or even slightly downward sloping, and you realize you are seeing the summit plateau, the edge of the enormous flat area that caps Olympus Mons like a table. The plateau extends across dozens of kilometers, visible now as a distinct darkening against the sky, where its far edge meets space. And somewhere on that plateau lie the calderas, the huge volcanic craters that mark where the mountain's magma chamber once lay far below, and where the surface collapsed inward when magma drained away. You continue climbing toward the plateau edge with renewed determination, the grade beginning to ease as the slope transitions from the steep upper shield to the flatter summit region. And within another 2 hours of walking, you reach the boundary, stepping from tilted terrain onto essentially level ground, the summit plateau of Olympus Mons, beneath your boots. The achievement feels significant, the main climb complete, the summit region reached, though you know the actual highest point lies somewhere ahead at the rim of the largest caldera. But you are here, on top of the tallest mountain in the solar system, standing higher than any human has ever stood on any world. The plateau surface is rough basalt, blocky and uneven. Lava flows and volcanic features covering the ground in chaotic arrangements, and walking across it requires attention to avoid tripping on the irregular terrain. The elevation here measures approximately 21,000 meters above the Martian datum, nearly 3 times higher than Everest rises above Earth's sea level. High enough that you are essentially in space, the atmosphere below and around you negligible, the sky black even at midday, with stars shining openly. The temperature in sunlight has risen to minus 10 degrees Celsius, warm for Mars at any altitude, the intense solar radiation striking the surface with minimal atmospheric absorption. You walk across the plateau, heading generally westward toward where the navigation display shows the caldera complex. And after perhaps 30 minutes of walking, you see it appear ahead, a line where the ground simply ends, dropping away into emptiness, the rim of the nearest caldera. You approach carefully, aware that the edge might be unstable despite its ancient appearance, and stop a safe distance back from where the rock falls away. The caldera opens before you, an enormous, roughly circular pit, perhaps 15 kilometers across at this point. Its walls dropping vertically for what appears to be thousands of meters, to a floor so far below it seems impossibly distant. The caldera is one of several that overlap at the summit of Olympus Mons, the volcanic craters formed by repeated collapses of the surface into voids left when magma drained from chambers below. And together, they create a complex of depressions covering an area of roughly 85 kilometers by 60 kilometers, an enormous scar at the mountain's peak. You walk along the rim, looking down into the depths, seeing the layered walls showing the history of the volcano. Lava flows stacked like pages, each collapse event creating a new crater that intersects and modifies the older ones. The scale is difficult to comprehend, The caldera so large that you cannot see across to the far rim, the distance and the curvature hiding it beyond the horizon. The floor of the caldera lies approximately 3 kilometers below the rim where you stand, a descent equal to a major mountain in its own right. And you can make out details down there. Lava flows and features on the floor, evidence of volcanic activity even after the collapse, eruptions that filled parts of the caldera with new material. The walls are not entirely vertical, but steep enough in most places that descending would be extremely dangerous or impossible. Sheer cliffs interspersed with steep slopes of loose debris. You have no plan to descend into the caldera, the rim itself being the goal, the highest accessible point being somewhere along these rim walls. You continue walking along the caldera rim, following its irregular curve, looking for the highest section, the true summit of Olympus Mons. The rim undulates, rising and falling by tens of meters as different lava flows created different levels. And you climb the higher sections, checking the altimeter to see which point registers the greatest elevation. After perhaps 2 hours of walking the rim, you find a section that seems slightly higher than the surrounding areas, a point where several lava flows merged to create a small rise. And your altimeter shows 21,900 meters, the highest reading you have recorded. This is likely the summit, the highest point on Olympus Mons, and therefore the highest point on Mars. Though without surveying the entire rim, you cannot be absolutely certain. But it is close enough, within meters of the true maximum. And you stop here and sit down on the ancient basalt and simply be present in this moment of arrival. The climb is complete, the goal reached. 8 days of continuous ascent from the landing site, far below and far away, across the plain and up the escarpment, and across hundreds of kilometers of shield slopes to this point. You have climbed Olympus Mons, standing now higher than any human has stood, higher than the summit of any mountain on Earth, on the edge of space, with the stars shining overhead and Mars spread below. The view from here encompasses an enormous region, possibly the entire visible hemisphere of Mars, depending on atmospheric clarity, the horizon lying hundreds of kilometers distant in every direction. To the east, the shield slopes fall away gradually, the gentle grade extending down and down until distance and dust obscure the lower elevations. To the north and south, the caldera complex extends, other rim sections visible, other craters overlapping in complex arrangements. To the west, beyond the caldera, the far side of the plateau stretches, and beyond that, the western slopes of Olympus Mons descend toward plains you cannot see from this angle. The planet curves noticeably, the horizon showing Mars's spherical shape, the small world's curvature apparent from this altitude. The sky is black directly overhead, deep purple near the horizon, stars everywhere visible even with the sun shining. The Milky Way, a pale band crossing from south to north. You feel weightless, almost. The reduced gravity and the sense of being at the top of everything combining to create a floating sensation. And you sit very still, breathing slowly, absorbing the experience, committing this moment to memory with intentionality. This is the summit, the place you came for, the achievement that justifies the years of training and the months of travel and the days of climbing. You are here, now, at the top of Olympus Mons. You stand and walk slowly along the summit rim, exploring the area around the highest point, looking down into the caldera from different angles and out across the plateau in various directions. Simply being here, occupying this space that almost no one will ever reach. The summit region feels timeless, the volcanic rock ancient and unchanged for millennia. The processes that shaped this place long since ended. The mountain now a static monument to Mars's more active past. The silence is absolute. No wind registering on your sensors. No movement except what you create yourself. The universe holding its breath around this high, empty place. You find a comfortable spot near the rim where you can sit with your back against a convenient rock and your legs stretched out before you. And you settle into this position to rest and to simply observe. The sun has passed its zenith and begun descending toward the western horizon. The afternoon aging toward evening, and you decide to stay here at the summit through sunset and night. Camping at this highest point rather than descending immediately. The decision feels right, honoring the mountain and the climb by spending time here, rather than rushing to leave. And you have supplies for several more days if needed. The rock beneath you and behind you is basalt, fine-grained and dark, volcanic glass present in small nodules, the surface pitted with tiny vesicles where gas bubbles were trapped as the lava cooled. You run your gloved hand over the texture, feeling the roughness through the suit material, connecting physically to the mountain that has been your world for the past week. The stone is utterly still, stable beyond any Earth mountain's stability. Mars having no tectonic activity to shift or tilt the rocks. No earthquakes or landslides, except those caused by impacts, or by the rare Marsquake from thermal stress deep in the planet's interior. Looking down into the caldera from your seat, you can see the complexity of its floor, multiple overlapping lava flows creating patterns of light and dark, channels where lava once flowed between different levels, areas where the floor appears fractured or collapsed in smaller subsidiary pits. The caldera is ancient. The collapses that formed it possibly occurring millions of years ago, during the last major active phase of Olympus Mons. And since then, the volcano has been quiet, perhaps extinct, though certainty about extinction is difficult with volcanoes, some remaining capable of reawakening after millions of years of dormancy. Most scientists believe Olympus Mons is done, its volcanic life complete. But uncertainty remains. You notice features on the caldera floor that might be vents, circular or irregular openings where lava emerged after the collapse. And you imagine what this place might have looked like during an active phase. Molten rock fountaining from the vents, lava lakes glowing red and orange, volcanic gases billowing into the thin Martian air. The eruptions would have been spectacular, perhaps visible from space, the summit region lit by incandescent flows, heat radiating into the cold atmosphere. But that was long ago, before humans existed, before Earth had civilizations, or written language, or technology. Olympus Mons, erupting in solitude, on an empty world, with no observers except perhaps microscopic Martian life, if such ever existed. The afternoon passes in quiet observation, your mind calm and still, thoughts arising occasionally, but not demanding attention. The experience of simply being here at the summit, filling consciousness without need for additional content. You watch the sun descend slowly toward the horizon, the small, pale disk tracking westward across the black sky. Stars visible all around it, the scene surreal and beautiful. The temperature begins to drop as the sun lowers, your suit increasing heating output automatically, maintaining comfort, while outside the temperature falls from -10 to -30 to -50. Eventually, you stand and deploy the shelter, setting it up a safe distance from the caldera rim, in a spot where the ground is relatively flat and protected from any possible wind. The shelter inflates and seals, and you crawl inside as the sun touches the horizon and begins to set. Through the camera views, you watch the sunset from the summit of Olympus Mons, the sun sinking into the black-purple sky, a brief blue glow appearing around it as the dust in the distant lower atmosphere scatters light at extreme angles. Then the sun dropping below the curve of Mars, and darkness spreading rapidly across the sky. The stars brighten impossibly, more visible than from any previous campsite, the high altitude and thin air creating observing conditions that approach space telescope quality. You can see details in the Milky Way that are invisible from Earth's surface, dark nebulae and bright nebulae, star clusters appearing as fuzzy concentrations of light, the galactic structure evident in the band crossing the sky. You identify constellations, or try to, but the stars are so numerous that the familiar patterns become difficult to pick out from the surrounding points of light. The sky too full of stars to navigate easily by traditional constellations alone. You watch the Martian moon's rise, Phobos first, moving quickly across the sky, a faint irregular dot of light, barely bright enough to see without magnification. Orbiting Mars in just over 7 hours, so it rises and sets multiple times per night. Deimos follows, even fainter, slower, taking 30 hours to orbit and thus appearing to move slowly westward against the stars. Both moons are tiny, captured asteroids rather than large satellites like Earth's moon. And from Mars's surface, they appear as bright stars rather than as disks showing visible features. You watch them track across the starfield, occasionally passing in front of background stars and briefly occulting them. Earth is visible again in the evening sky, bright blue-white, and you look at it for a long time, thinking about the distance separating you from that world, the months of travel that brought you here, the journey that will eventually take you back. The climb is complete, the summit reached, and soon the descent will begin, retracing the route down the shield slopes and the escarpment and across the plain to the lander. Then, the ascent to orbit, the long voyage through space, the return to Earth and its thick atmosphere and strong gravity. But those future events feel abstract, less real than this present moment, sitting at the summit of Olympus Mons, watching stars wheel overhead. You eat an evening meal, drink water, check the suit systems, finding everything nominal, and prepare for sleep. The mission clock shows 8 days since leaving the landing site. 8 days of continuous journey across Mars and up its tallest mountain. And tomorrow will begin the return journey, heading down from this high point. But tonight you sleep at the summit, 22 kilometers above the Martian datum, on the highest ground any human has ever reached, under a black sky filled with stars. The mountain enormous and silent beneath you, ancient beyond easy comprehension, and patient beyond any human understanding of time. You close the camera views and lie back on the inflatable floor of the shelter, closing your eyes, letting sleep approach. Dreams come gently, vague images of stone and stars, of climbing and arriving, of standing on the edge of the caldera, looking down into geological time. The night passes in profound cold and profound stillness. The summit wrapped in darkness and silence, and you sleep peacefully, at the top of the solar system's tallest mountain. Morning at the summit brings a dawn unlike any other you have experienced. The sun rising over the eastern horizon, while stars still shine overhead. The black sky barely lightening as the small pale disk climbs above the curve of Mars far below. You emerge from the shelter into the pre-dawn darkness and stand looking east, waiting for the sunrise, watching the first light touch the upper atmosphere far below you and create a faint glow along the horizon. The sun appears, small and distant, and its light strikes the summit plateau, illuminating the dark basalt, casting sharp shadows from every rock and irregularity in the terrain. The temperature remains brutally cold despite the sunlight, the thin atmosphere unable to trap any warmth, and you feel the suit's heating system working to maintain comfortable conditions inside. You pack the shelter efficiently, your movements practiced after more than a week of daily deployment and retrieval, and you check suit systems, finding all reserves adequate for the descent. The plan for today involves exploring the caldera complex more thoroughly, walking the rim of multiple craters, seeing what features exist at the summit before beginning the long journey back down. You have climbed 22 kilometers to reach this place, and now you want to understand what this summit holds. What stories the calderas tell about the mountain's volcanic past. The exploration begins with simply walking east along the rim of the nearest caldera, following the edge where the plateau drops away into the enormous crater. The rim beneath your boots consists of layered basalt, dark grey to almost black rock, that formed from lava that flowed and cooled in repeated episodes over millions of years. Each layer represents a different eruption, a different flow that spread across the summit before the caldera collapse occurred. And the layers stack one upon another like pages in a book written in stone. You can see the individual layers where erosion or small rockfalls have exposed the edge. Each band a slightly different shade, some thicker and some thinner, depending on how much lava flowed during that particular eruption. The rock is rough under your gloved hands when you crouch to examine it, the texture showing tiny holes where gas bubbles were trapped as the lava cooled rapidly in the thin Martian atmosphere. Walking along the rim, you notice how the edge is not perfectly smooth but irregular, with small promontories jutting out and indentations cutting inward, the collapse that formed the caldera having happened unevenly. The drop-off is sheer in most places, a vertical or near-vertical cliff descending into the crater, and you stay a safe distance back from the edge while still being able to see down into the interior. The caldera floor lies about 2 kilometers below the rim. Here, too far down to see much detail, but you can make out darker and lighter patches that might represent different rock types or different ages of material on the floor. The walls show the same layering visible on the rim, but here the layers are exposed in a vast vertical section, a geological history standing upright for anyone who can read it. You continue walking and come to a place where 2 calderas overlap, the rim of one cutting across the older rim of another, and the geometry becomes complex and fascinating. The overlap shows clearly which caldera formed first, the older one partially destroyed by the collapse that created the newer one. And you can trace the sequence of events just by looking at how the rims intersect. This kind of overlapping happens when a volcano remains active over long periods, the magma chamber beneath the summit draining and refilling multiple times, each drainage causing a collapse that creates another caldera. Olympus Mons has at least 6 distinct calderas visible from orbital imagery, all nested and overlapping at the summit, evidence of a long and complex volcanic history spanning hundreds of millions of years. The largest caldera in the complex measures roughly 80 kilometers long and 60 kilometers wide, an enormous oval depression that could swallow entire mountain ranges on Earth. Standing at its rim and looking across to the far side, the distance is too great to see the opposite edge clearly. The crater so vast, it creates its own horizon within the summit plateau. The floor of this caldera lies about 3 kilometers below where you stand, deeper than the Grand Canyon on Earth, and the walls descend in a series of terraces and cliffs rather than one smooth slope. You can see rockfall deposits at the base of some cliff sections, loose material that has tumbled down over the ages, and you can see what might be lava flows on the caldera floor, evidence that eruptions continued even after the collapse occurred. Moving to a better vantage point, you find a spot where you can see into multiple calderas at once, the overlapping craters creating a landscape of nested depressions. The view is strange and beautiful, the geometry unlike anything you have seen before. Circles within circles, rims crossing rims, each crater telling part of the story. The stone here is cold and dark, and the sky above is nearly black even with the sun shining, and the combination creates a stark beauty, a landscape of extremes. You sit on a rock outcrop near the rim and just look, taking time to absorb the scale and the silence and the reality of where you are. The calderas formed through collapse, not through explosive eruption the way some volcanic craters form on Earth, and the evidence for this lies in the structure. If these craters had formed from explosions, the rims would be built up from ejected material raised above the surrounding terrain. But instead, the rims are level with the plateau, or even slightly depressed. The collapse happened when magma drained from the chamber beneath the summit, removing support from the overlying rock, and the surface above simply fell inward, sinking down to fill the void left by the departed magma. The process might have happened suddenly or gradually, and it might have been accompanied by small eruptions or not, but the primary mechanism was subsidence rather than explosion. You walk to the edge of a smaller caldera, one of the more recent collapses, based on the sharpness of its rim and the lack of erosion on its walls. This crater measures perhaps 15 kilometers across, small by the standards of Olympus Mons, but still enormous by any human measure, and its floor lies about 1.5 kilometers below the rim. The walls here are very steep, nearly vertical in places, and you can see fresh rockfall scars where material has broken loose and tumbled down in the relatively recent past. Though recent might mean thousands or even millions of years on Mars, the interior shows less accumulation of debris than the older, larger calderas, suggesting this collapse happened more recently in geological terms, perhaps only a few million years ago, rather than tens or hundreds of millions. Looking into this younger caldera, you notice features on the floor that might be frozen lava lakes, flat, smooth areas where molten rock pooled and solidified after the collapse occurred. The lava lakes would have formed if eruptions continued after the caldera formed, lava rising from below and filling the depression partially before cooling and freezing in place. The surfaces of these potential lava lakes appear smooth from this distance, lacking the rough, chaotic texture of broken rock, and they occupy the lowest parts of the caldera floor, where liquid would naturally pool. You make a mental note of these features, knowing they represent some of the youngest volcanic activity on Olympus Mons, the final expressions of a volcano winding down toward extinction. The sun climbs higher as the morning progresses, and the shadows cast by the caldera rims shift and shrink, changing the appearance of the landscape. You continue your exploration, walking along different rim sections, seeing how each caldera has its own character, its own particular geometry and depth. Some of the overlaps create complex features, where the rim of one crater serves as the wall of another, the geology intricate and layered. You find yourself moving slowly, stopping often, looking carefully at the rock and the structure, trying to understand what you are seeing, trying to piece together the history written in stone. At one point, you discover what appears to be a volcanic vent on the summit plateau, a small depression surrounded by a low rim of darker material, possibly a source point for one of the lava flows that covered this area before the calderas formed. The vent is small, perhaps 20 meters across, and partially buried by later deposits, but its circular shape and raised rim are distinctive. You approach carefully and examine the rim material, which appears to be volcanic cinders or spatter, fragments of lava ejected from the vent during an eruption and then frozen in place where they landed. This kind of feature is common on volcanic summits, marking spots where lava reached the surface through cracks and fissures before the main caldera collapses occurred. The exploration continues through midday, and you work your way around the caldera complex, seeing new perspectives on the overlapping craters with each change in position. The physical act of walking at this altitude feels almost dreamlike, your boots touching down on rock that sits higher above a planetary surface than any other ground in the solar system. You pause frequently, not from fatigue, but from the desire to truly see this place, to register the details, to remember what the summit of Olympus Mons looks like from ground level rather than from orbit. The helmet filters the sunlight and displays data about your location and the surrounding terrain. But mostly, you just look with your own eyes at the stone and the sky. You come to a section of rim where the collapse appears to have happened in stages, the wall descending in a series of terraces, like giant steps leading down into the caldera. Each terrace represents a level where the collapse paused temporarily before continuing downward, the rock settling in increments rather than falling all at once. The terraces are uneven, some wide and some narrow, and they create a stair-step profile on the interior wall that differs from the sheer cliffs elsewhere. You wonder what it would be like to descend one of these terraced walls, to climb down into the caldera and stand on the floor looking up. But the technical challenges would be significant, and the time required would exceed your mission parameters. From this vantage point, you can see across the entire caldera complex, and the pattern of overlapping craters becomes clear, each circle cutting across older circles, creating a geometry that reveals the sequence of collapse events. The oldest calderas are the most eroded, their rims rounded and softened by billions of years of weathering despite the thin atmosphere, while the youngest calderas have sharp rims and clean walls. You try to count the distinct craters, but the overlaps make it difficult, boundaries blurring where one caldera intersects another. And you settle on identifying at least 6 major collapses and several smaller ones. The entire complex covers an area of roughly 80 by 120 kilometers. An enormous scar at the mountain's summit marking the location of the magma chamber that fed this volcano for hundreds of millions of years. A small crater within one of the larger calderas catches your attention. A pit, perhaps 50 meters across, that appears to have formed more recently than the main collapse. This could be a fumarole or a secondary vent where volcanic gases escaped after the major caldera formed, the ground collapsing into a void created by escaping gas or by minor magma withdrawal. You walk closer to examine it, staying cautious of the edge, and you see that the pit has steep walls descending, perhaps 20 meters, before the shadows become too deep to see the bottom. The rim shows no evidence of explosive activity, just a clean circular break where the surface fell away, and the feature looks fresh enough that it might have formed within the last million years, possibly much more recently. The rocks around this smaller pit are darker than the surrounding terrain, and you crouch down to look more closely at the surface texture. The stone here has a glassy quality. In places, areas where the rock melted and then cooled quickly, creating a smooth surface, quite different from the rough basalt that dominates most of the summit. This glassy material might represent the final activity at this spot, heat from below causing the rock to partially melt before the system shut down permanently. You touch the surface gently with your glove, feeling the smoothness even through the thick material. And you think about the heat that once existed here, the molten rock that once moved beneath this ground, now gone cold, perhaps forever. Standing up, you turn in a slow circle, looking at the entire summit plateau spread out around you. The calderas, the frozen lava flows, the small vents and pits scattered across the landscape. This place represents the end result of volcanic processes that operated over hundreds of millions of years, building the mountain layer by layer through countless eruptions before finally going quiet. The last eruption on Olympus Mons might have occurred 2 million years ago, or 20 million, or even more recently than that. Scientists are still uncertain about the exact timing. The mountain could be extinct, or it could merely be dormant, sleeping but not dead, though the likelihood of future eruptions seems very low, given Mars's cooling interior and declining geological activity. You find a comfortable spot on the rim where you can sit and rest while looking out over the caldera interior and across the summit plateau. The suit compensates for the cold and the vacuum, maintaining a comfortable environment inside, while the temperature outside hovers around -100 degrees Celsius in the shade. You sip water from the suit's system and eat a small ration, the mechanical process of eating through the suit's port, familiar now after days of practice. The food is bland but adequate, and the water tastes faintly of the recycling system. But neither matters much when you are sitting on the summit of the solar system's tallest mountain, looking into a volcanic crater larger than some countries on Earth. The afternoon light begins to shift as the sun passes its highest point and starts descending toward the west, and the shadows in the calderas lengthen gradually, darkness creeping across the floors from the eastern walls. The change happens slowly enough that you do not notice it moment to moment, but when you compare the current shadow positions to what you remember from an hour ago, the difference is clear. You watch the light move across the landscape, simple physics creating beauty, the angle of illumination revealing textures and features that were invisible when the sun was directly overhead. The layering in the caldera walls becomes more apparent as shadows emphasize each band, and the floor features gain depth and definition as the low-angle light creates relief. You spend the afternoon moving slowly around the calderas, and as the hours pass, the quality of light continues changing, the shadows growing longer, the colors of the rock shifting subtly as the sun descends toward the western horizon. There is no hurry now, no schedule to keep, except to find a suitable spot for the night shelter before darkness comes. And you decide to stay here at the summit for one more night before beginning the descent tomorrow. The exploration has been thorough. You have seen the major features of the caldera complex, and now the experience shifts towards simply being present in this place, watching the day end from the highest ground on Mars. The summit plateau extends in all directions around the calderas, and you walk outward from the rim to find a spot on the open ground where you can set up the shelter with a clear view to the west. The terrain here is relatively flat, covered with a layer of fine dust over the solid basalt, and you find a location that seems stable and free of large rocks. You set down your pack and begin the familiar process of deploying the shelter, the flexible structure unfolding and self-inflating, becoming rigid as the internal framework locks into place. The work takes perhaps 20 minutes, and when finished, you have a small pressurized space where you can remove the helmet, eat a proper meal, and rest comfortably. Before entering the shelter, you stand outside and watch the sun dropping lower in the sky, the small pale disk approaching the horizon, while the sky around it remains nearly black. The sunset from this altitude will be different from anything you experienced during the climb. The atmosphere is so thin here that twilight will be brief. The transition from day to night happening quickly once the sun disappears. You estimate perhaps another 2 hours until sunset, and you decide to spend that time outside, watching the light change, seeing what the late afternoon reveals about this landscape. The color of the sunlight appears slightly different at this low angle, less white and more amber, though the change is subtle on Mars compared to the dramatic color shifts of Earth sunsets. The thin atmosphere scatters very little light, so there is no diffuse glow filling the sky, just the direct illumination from the sun and the darkness everywhere the light does not reach. The shadows cast by rocks and small irregularities in the terrain stretch out across the plateau, long dark lines extending toward the east, and your own shadow reaches meters away from your boots, a distorted shape on the dusty ground. You walk to a high point on the rim where you can see in multiple directions, and you stand there watching as the light paints the caldera walls with amber and gold. The eastern walls are already in shadow, deep darkness filling that side of the craters, while the western walls glow in the direct sun, the layered rock showing every detail. The contrast creates a striking division, half the caldera bright and half dark, a line of shadow slowly advancing across the floor as the sun drops. The beauty is quiet and subtle, not dramatic but persistent, the patient beauty of geology and light. Looking south from your position, you can see across the summit plateau to the edge of the mountain. And beyond that edge, the atmosphere of Mars becomes visible as a thin layer of haze far below. The planet curves away beneath you, the horizon perhaps 300 kilometers distant from this height. And the late afternoon light illuminates the atmosphere, creating a faint band of color above the planet's limb. The color is delicate, a pale peachy orange band that marks the boundary between Mars and space. And above that band, the sky fades quickly to black, where stars are already visible. You turn west and see the sun hanging perhaps 15 degrees above the horizon now, the landscape between here and there lost in distance and haze. The other volcanoes of the Tharsis region are not visible from this angle, but you know they exist out there. Olympus Mons and Olympus Mons and Martian Mons. 3 other enormous shield volcanoes arrayed in a line southeast of Olympus Mons. All 4 volcanoes formed from the same geological hotspot or tectonic weakness in Mars's crust, and together they dominate the western hemisphere of the planet. Mountains so large they affect the planet's climate and atmospheric circulation. The temperature continues dropping as evening approaches, and you check the suit readout showing exterior temperature now at -110 Celsius and falling. The cold does not touch you inside the suit, but knowing the temperature creates an awareness of the environment, a respect for the conditions that exist on this mountain. Earth's highest peak, Mount Everest, reaches temperatures of -40 Celsius on a cold day at the summit, challenging but survivable with proper equipment. Mars at this altitude reaches cold that would freeze carbon dioxide out of the air if the air were thick enough to hold carbon dioxide at this pressure. Cold that represents a completely alien environment where nothing from Earth could survive unprotected. You sit on a boulder and watch the sun's continued descent, and the peace of the moment settles over you like the gathering darkness. There is nothing to do now except witness the end of the day. No data to collect or samples to document. Just the experience of being here as the light fades. The silence is absolute. No wind at this altitude to create even the faintest sound. No atmosphere thick enough to carry vibrations. Just the quiet hum of your suit systems and the sound of your own breathing inside the helmet. The stars above grow brighter as the sun drops lower, the contrast increasing between the darkness of space and the small amount of scattered light remaining in the atmosphere below. You can identify constellations now, the same patterns visible from Earth, but seen from a different vantage point, the perspective shifted by the distance between the 2 planets. Mars orbits about half again as far from the Sun as Earth does, and this difference changes the apparent positions of nearby stars slightly, though the effect is subtle and you are not skilled enough to notice it without instruments. A movement catches your eye, and you look up to see Phobos crossing the sky, Mars's larger moon moving visibly against the background stars. Phobos orbits very close to Mars, only about 6,000 kilometers above the surface, and it completes an orbit in just 7.5 hours, rising in the west and setting in the east because it orbits faster than Mars rotates. From the summit of Olympus Mons, you're about 22 kilometers closer to Phobos than someone standing at Mars's datum level. A trivial difference in the scale of its orbit, but enough to make you feel you are reaching up toward space. Phobos appears as a bright star-like point, moving steadily eastward, taking perhaps 4 hours to cross from one horizon to the other, as seen from this latitude. The moon is small and irregular, roughly 22 kilometers across at its widest, a captured asteroid rather than a formed moon, and its surface is heavily cratered from billions of years of impacts. You watch it move, thinking about the fact that Phobos is slowly spiraling inward toward Mars, tidal forces gradually stealing its orbital energy. And in perhaps 30 to 50 million years, it will either crash into Mars or be torn apart by tidal stress to form a ring system around the planet. The sun touches the horizon, and you stand up to watch the final minutes of the day. The small disk, flattening slightly as it meets the distant edge of Mars. The sky around the sun shows subtle color, bands of orange and pink and purple layered in the thin atmosphere, the dust particles scattering the light into these delicate hues. The colors are softer than Earth's sunset colors, less saturated, more like watercolors than oils, and they fade quickly above and below the sun's position. You watch in silence as the disk sinks lower, half gone now, then more than half, the light on the summit plateau fading rapidly. The sun disappears below the horizon, the last bright point vanishing, and the light drains from the landscape within minutes, no prolonged twilight to ease the transition from day to night. The sky darkens swiftly, the bands of color fading, the stars growing brighter and more numerous as the last scattered sunlight leaves the atmosphere below. Within 15 minutes of sunset, the sky is fully dark, the transition complete, and you stand on the summit of Olympus Mons under a sky filled with stars. The Milky Way beginning to show itself as a bright band arcing across the heavens. The temperature drops another 10 degrees in the first hour after sunset, the ground radiating away the small amount of heat it absorbed during the day, and space pulls all warmth away into its infinite cold. You activate the suit's exterior lights to illuminate the area around the shelter, and the beams cut through the darkness, showing the red-brown stone and the grey dust. You move to the shelter entrance and cycle through the airlock, and once inside, you remove the helmet and breathe the recycled air, grateful for the break from the confined space of the suit, even though you will put the helmet back on in a few hours when you go outside again to see the night sky properly. After eating and resting for a few hours inside the shelter, you suit up again and go back outside into the Martian night, wanting to experience the darkness from the summit, to see the stars without any atmosphere between you and space. The helmet seals and the suit pressurizes, and you cycle through the airlock back into the vacuum and cold, your lights illuminating the ground as you walk away from the shelter toward the caldera rim. The stars overhead are extraordinary, brighter and more numerous than you have ever seen them, even from high altitude on Earth, because here there is essentially no atmosphere to dim their light or scatter it into a background glow. The Milky Way dominates the sky, a river of light flowing across the darkness from horizon to horizon, and you can see structure in it. Dark lanes where dust clouds block the light from stars behind them, brighter patches where star clusters and nebulae concentrate. The core of the galaxy lies below the horizon at this time of night and season, but the spiral arms spread overhead in a magnificent display, thousands upon thousands of stars visible individually, and millions more blending into the soft glow of the galactic plane. You turn off your helmet lights to see the stars better, letting your eyes adjust to the darkness, and the sky becomes even more impressive as faint stars emerge that were invisible with the lights on. Standing at the caldera rim, you look up and try to find Earth, knowing it should be visible somewhere in the sky as a bright blue-white star, distinctive among the other points of light. You remember the approximate position from the mission briefing, and you search the sky in that region, finding several bright stars, but unsure which one is home. Finally, you activate the suit's navigation system and ask it to indicate Earth's position, and a small indicator appears in your helmet display, pointing to a bright star low in the western sky. There it is, Earth and Moon together, too close to separate with the naked eye, appearing as a single bright point, and you stare at it, thinking about the fact that everyone you have ever known lives on or near that distant spark. The distance between Mars and Earth varies depending on where both planets are in their orbits, ranging from about 55 million kilometers at closest approach to over 400 million kilometers when they are on opposite sides of the Sun. Right now, the distance is roughly 200 million kilometers, and the light you see from Earth left that world about 11 minutes ago, traveled through space at 300,000 kilometers per second, and arrived at your eyes here on the summit of Olympus Mons. The radio signals from Mission Control take the same 11 minutes to reach you, and your replies take another 11 minutes to return, creating a 22-minute communication delay that makes conversation impossible and requires all interactions to be conducted through messages and planned updates. You look at other stars, finding Mars visible from Earth in the night sky, a bright reddish star that has fascinated humans for thousands of years before anyone understood what it was. From Earth, Mars appears to wander against the background stars, sometimes moving forward and sometimes appearing to move backward in retrograde motion as Earth overtakes it in the inner orbit. And this wandering gave Mars its name in many cultures, associated with gods of war and chaos and change. Now you stand on Mars, looking back at Earth, the perspective reversed, and you wonder if anyone on Earth is looking up at Mars right now, seeing the reddish star in their sky, not knowing that someone stands here looking back. Deimos, Mars's smaller and more distant moon, is visible as a very faint star near the zenith, much dimmer than Phobos and moving much more slowly across the sky. Deimos orbits about 20,000 kilometers above Mars and takes 30 hours to complete one orbit, so it rises in the east and sets in the west like a normal moon, moving slowly enough that its motion is barely perceptible over a few minutes. The moon is tiny, only about 12 kilometers across, another captured asteroid, and from the surface of Mars, it appears only slightly brighter than Venus appears from Earth, barely noticeable, unless you know where to look. You walk slowly along the rim, looking up more than forward, navigating by the stars and the faint light they cast on the landscape. The ground is barely visible, just vague shapes and shadows, but your boots find purchase on the solid rock, and you move carefully, aware that a fall in the darkness could damage the suit or injure you. The experience feels dreamlike, walking on the summit of an enormous mountain, on another planet under a sky filled with stars. The silence complete, except for the sounds of the suit systems and your breathing. You think about the journey that brought you here, the training and the travel, the landing and the climb, all leading to this moment under the Martian stars. After an hour of walking and stargazing, you return to the shelter and stand outside looking up, one more time before going in for the night. The sky has rotated slightly as Mars turned beneath it, new stars rising in the east, while others set in the west. The slow wheel of the heavens continuing as it has for billions of years, and will for billions more. You think about the people who will come here after you, future climbers of Olympus Mons, future explorers of Mars, and whether this place will someday be familiar and routine rather than exotic and remote. Perhaps in 100 years, there will be a base here, shelters and equipment, and people coming and going, the summit of Olympus Mons becoming just another location on a settled planet, rather than the distant goal of a dangerous expedition. But tonight, you are alone here, the only human on Olympus Mons, possibly the only human on Mars depending on where other missions are operating. And the solitude feels profound and peaceful. You have achieved what you came to do, climbing from the base to the summit, standing on the highest ground in the solar system, seeing the calderas and the mountain structure, experiencing Mars from this unique vantage point. Tomorrow, you will begin the descent, retracing your path down the slopes to the escarpment and eventually to the landing site, and from there, returning to orbit and eventually to Earth. But tonight, you are here, and the moment is complete in itself. You enter the shelter and seal the airlock, removing the helmet once the pressure equalizes, and you sit down to remove the rest of the suit. The process is familiar now, each seal and connection releasing in sequence, the suit coming apart in sections until you can step out of it completely. The shelter's interior is warm and lit, a small, comfortable space that feels enormous after hours in the confinement of the suit. And you move freely in the lightweight interior clothes, stretching and relaxing. Before sleeping, you sit near the shelter's small window and look out at the stars, the transparent panel giving a limited view, but enough to see the Milky Way and the darkness. You think about the mountain beneath you, the 22 vertical kilometers of layered basalt that you climbed over the past week, each layer representing a lava flow from some ancient eruption when Mars was young and geologically active. The mountain is old, perhaps 3.5 billion years old, formed during the same early period when Mars had a thicker atmosphere and possibly liquid water on its surface. Olympus Mons has stood here through almost the entire history of Mars as a planet, growing taller through millions of eruptions before finally going quiet. And it will stand here billions of years into the future, slowly eroding but changing little in the timescales of human history. You think about the journey down that begins tomorrow, the long descent that will take as many days as the ascent took, returning through the elevations and landscapes you passed on the way up. The climb will be easier in some ways, going down, gravity helping rather than hindering, but harder in others, the constant braking and controlled descent requiring concentration to avoid tumbling or moving too fast. You will retrace your path down the upper slopes and middle slopes and lower slopes, watching the escarpment rise up as you approach it from above. Then, carefully descending that enormous cliff to reach the plains. From there, you will trek back to the lander, seeing the mountain recede behind you, and finally launch back to orbit, leaving Olympus Mons behind. But those events are tomorrow and the days after, and right now you are here at the summit, resting after a successful climb, comfortable in the shelter, under Martian stars. The achievement feels quiet rather than dramatic, satisfaction rather than triumph, the simple completion of a goal that required patience and effort and care. You climbed the solar system's tallest mountain by placing one boot in front of the other for a week, walking up gentle slopes, taking time to rest, moving steadily upward until there was nowhere higher to go. The method was simple, the execution was careful, and the result was success. Sleep comes easily, your body tired from the day's exploration and ready for rest, and you drift off, thinking about stars and stone and the cold silence outside the shelter walls. Your dreams, when they come, are filled with images of climbing, of red landscapes under dark skies, of looking down from high places and seeing Mars spread out below. The dreams are peaceful, without anxiety or fear, Just the experience of being here, translated into the language of sleep. The mind processing the day's experiences and weaving them into patterns that will become memory. The night passes quietly on the summit of Olympus Mons, the shelter maintaining its small bubble of warmth and pressure, while outside the temperature drops to -130°C, and the vacuum of space presses against the thin walls. The stars wheel overhead in their ancient patterns. The Milky Way rotates across the sky. Phobos rises and sets and rises again in its rapid orbit. Mars turns beneath the stars. The sun approaches from below the eastern horizon, and eventually, dawn begins to lighten the sky above the thin atmosphere far below. Though darkness persists at the summit, where the air is too thin to scatter light. You wake naturally as the suit's alarm provides a gentle notification that sunrise is approaching, and you sit up in the shelter, rested and ready to begin the descent. The journey continues today, different from yesterday's journey, but connected to it, part of the same long experience of exploring Olympus Mons. You prepare a simple breakfast, eating slowly while looking out the window at the stars fading as day approaches, and you think about home and mission and what comes next. The mountain has been climbed, the summit reached and explored, and now the path leads downward, back to the lander, back to orbit, back eventually to Earth, carrying the memory of this place and these days under alien skies. The dawn light begins to touch the upper atmosphere far below, creating a faint glow on the eastern horizon, and you watch as the sky slowly transitions toward day, the stars dimming, the darkness lifting. Soon you will suit up and pack the shelter and begin walking down the slopes, leaving the summit behind, but carrying the experience forward. The knowledge of what it feels like to stand on the highest ground in the solar system, to climb Olympus Mons from base to peak, to see Mars from this extraordinary vantage point. The journey has changed you in small ways that you will only understand later, given you a perspective that comes from traveling far and climbing high, and standing in places where humans have never stood before. The sun rises, small and pale in the eastern sky, and the day begins. You begin packing your equipment, preparing for the descent, and the quiet satisfaction of the climb settles into your thoughts, a warm feeling of completion and achievement. You climbed Olympus Mons, stood on its summit, watched sunset and stars from the highest point on Mars, and now you carry that accomplishment forward into whatever comes next. The mountain stands eternal and patient behind you as you prepare to leave, and it will stand here long after you are gone, waiting for the next visitor, the next explorer who comes to walk its slopes and stand at its peak, dreaming of distant mountains under alien skies.